Hello, guys. Hello. Hello. Good, guys. Thank you for coming. I'm Cássio Pereira. I'm the chapter leader of DevOps here in Poland. We just started maybe 2 months ago, 3 months ago. Basically, we're a community to share knowledge and to share information and just to enjoy and meet people and so on. We already had 3 sessions, 1 online and two in person. This is the 4th one. Today we're gonna listen to Natalia talking about cyber attack, learn your lesson. Then Pawel will be talking about security testing for Terraform Templates. I want to ask you 2 things. First one, join our Discord community. We have a Discord channel there. We can debate and talk about a lot of things, security. And join our meetup group also, so you'll be aware when we have sessions and so on. Usually it will be online sessions, as also in some place around Krakow. Okay, guys, thank you for coming. It's a pleasure to meet each one of you. And Natalia, please.
Hello. Everyone, 1 second. The microphone. Not working. Oh? Yeah, cool. Nice to see you here, actually. So today we are going to talk about cyber attacks. Big companies are targeted every day, but what's the real scale of the problem? Today is 12th of October. Only 2 days ago, US airports were targeted by the DDoS attack. 12 airport sites were down. HIP, the company's IT infrastructure and production paralyzed. Overwatch 2, DDoS attack. Indianapolis Housing Agency, ransomware attack. Transit swap, hackers stole about 21 million. MI5, security service public site taken down for hours. Alia Servizi Adenziali, cyber attack on a waste management company in Italy. Fast Company, content management system hacked. The Chilean judiciary, massive leak of emails. Leonardo da Vinci University Center, application server hacked. Optus, cyber attack compromising customer information. Wintermute, 160 million stolen from crypto trader. Italian Ministry of Environment, Twitter account defaced. DDoS attacks, ransomware, theft. These are just several of a lot of more that happened only last month. Let's talk about how the real attacks are measured. First factor will be money. Of course, we are hearing about money in the real world every day. The world is driven by money, and the biggest cyber attacks can cost millions or billions of dollars. Then we have numbers of people. I think that we look differently on a cyber attack that's affecting only 1 person and millions of people. Then we have amount of data. Some cyber attacks can affect gigabytes or even more of data. That can be company data, email addresses. That can be credit card data. And the last but not least, some cyber attacks can cause death. Today's hospitals are increasingly targeted by ransomware attacks. And this is why we should look at the hackers and what they do for us. Before we start talking about one of the biggest attacks of last years, let's consider a cyber attack kill chain. Actually, when we talk about the kill chain, we usually think about the 7-step one discovered by Lockheed Martin a few years ago. But for the purpose of this presentation, we will talk about the simplified one that was presented by UK National Cybersecurity Center. Here we have only 4 steps, and it's for more general purpose than just a malware infection. So we have surveys, which is selecting the target, looking for the information, searching for the information, data, something connected to the actual target we selected. Then we have delivery. This is the first entry point to the systems. Here the hacker don't want to get to the actual goal, to the target, but just be in the system. Then we have the breach. which is exploiting the vulnerabilities to get access to more systems that can give him access to valuable information, data, or money. And the affect stage. Here the hacker wants to achieve the goal, so steal money or exfiltrate the data and things like that. Let's look at the DOS attack. So first we have the survey search. Here the hacker will look for the targets, the information, will select the targets. Then we have the delivery stage. Here he will exploit the targets, so send malware probably, or ask them to download something. The breach stage, there he will be using the malware to gain the access to their computers to create the botnet. And the last stage is the affect stage. Here he would carry the DOS attack using the botnet. On July 14 and 15, the Twitter was attacked by hackers. But what was before the attack? The survey stage. Reading the code documents, we can see that the hackers gained the first access to the systems on 3rd of May. So we can pursue that days before he gained some information. For example, the names of the employees, the telephone numbers, the VPN provider. He also prepared the fake login page of the VPN provider used by Twitter and or how to use it. Then we have the delivery stage. He already gained the information he wanted to use, so he used something called social engineering. This is the very familiar one, I think. He just called the targets. I mean, he had a list of employees, so it wasn't that bad. Oh, okay, he used maybe something like this, sorry. Called them, he claimed that he was from the IT department. He made some story about not working VPNs and some links for the fake website, and just simply asked them for a login. Of course, some of the first tries didn't work, employee didn't believe him, so he had to use the whole list of contacts, and after some time, he gained access to the Twitter internal network. The first employee that gave him the access actually didn't have the access to the whole network, only the part of this, because he was just new for the Twitter. The thing that the hacker used here is the COVID situation. So the transition from the office work to the remote work, everything was done in a rush. And the systems didn't work properly sometimes. Hearing new employees was tricky. They didn't receive the proper training, and the hacker used that. When gaining the access to the internal network, he could search through the Slack, see some websites, see the list of the employees and the contacts, and he used that to target another employees having access to the account support tools, which were used to provide information to court. When he gained this, he could do anything with Twitter accounts, delete it, change the email, change the password, send some fake notification, or even tweet from this account. That's a lot of, this is really privileged. I mean, thinking about the systems, we usually don't have access to post something from the name of another person, even if we are an employee. I'm sorry for the screenshot, but this is the best quality I could get. So we can see here that this is some account from the Twitter, and the person that hacked the Twitter could do anything with the email, edit, detach it, and actually this kind of situation skip the second factor provided by the user of the Twitter. And there comes the fourth stage, which is affect. He wanted just to sell the access somehow, just to simply make money. So the hacker posted posted an advertisement on one of the hackers' forums, telling that he has an access to the Twitter internal network and the tools that can give him some privilege just to change the emails and password. But you know, when you are posting something on hacker forum, that's usually not everyone just believes you, so you have to prove it. So he did it, actually. He took one account from the public, from the users of this forum, and just changed the email, changed the password, and took over this account. Later, he also posted this advertisement that he wanted to sell the OG accounts. OG stands for the original gangster. That's not commonly used, maybe, but it's just simply the account that was taken for the early users, containing just one letter, one word, one character. This is valuable for hackers. They're just hyping it and can pay for it thousands of dollars. As you see here, the price was estimated between $2,000 and $3,000 for this one nickname. Actually, he was selling quite a lot, but it wasn't enough for him. I mean, when you do a cyber attack, usually you want to gain, you want to receive a lot more than just a few thousands. So there is another stage of the attack, the public one. He had access to verified accounts, could post from there, and he used it to post from crypto traders' accounts or accounts connected to crypto trades. He did just simply advertise the crypto for health. I mean, the COVID situation was still on, so he used that and advertised cryptoforhealth.com. On the website, we can read that that he was giving back to the community twice as much as they sent him. And the post was posted from 45 accounts, like Joe Biden, Jeff Bezos, Elon Musk, and some company like Uber. So the July 2020 Twitter attack happened roughly in 24 hours. The first posted advertisement on a public account was about 4 p.m. on 15th of July. But the Twitter posted that they are aware of the attack at 6 p.m. So it was 2 hours that the advertisements were online. Later, we can read that 130 accounts were targeted. 45 accounts were tweeted from. 36 accounts had the DEM inbox access and downloaded. And 8 accounts downloaded your Twitter data, which is like the whole set of data that Twitter collects about the users. That's actually quite a lot, thinking about this 2 hours and some hours before, because the attack, since the second targeted employee, it was only 6 hours. Also, 415 Bitcoin transactions were sent to the scammers' accounts, and estimated 12.86 Bitcoin was stolen from the victims. This amount contains the money sent to the Crypto for Health and also selling the OG accounts. The attack wasn't that much. I mean, the hackers had privilege to do a lot of more, but they were just children. The hackers were Mason Shepard, age 19, Nima Fazeli, age 22. But the main character was Graham Evan Clark, of age 17, living with his parents in Florida. This is the one that hacked first, that gained first access to the Twitter network. Later, after the attack, Twitter hired Peter Meczatko, one of the most famous hackers of 2000, And Zatko had to improve Twitter security, which was mostly looking at the systems of people, training them. But as we know, Zatko was fired in January this year. He was working at Twitter roughly about a year. After this, the whistleblower complaints were shown to the public. But what was there? What we don't know about the Twitter system that Peter much Zatko knew. These are just some of the information that were made public. This is the ones that I chosen because of the attack that happened before. This is the information that are crucial for the systems to know. There was lack of access management system. More than half of 8,000 employees had access to the production environment. That's quite a lot. 8,000 people working on Twitter, some support, something else, and these more than 4,000 people had access to the live data, so your data, your name, your surname, your cookies, everything. Zatko also claimed that this access weren't observed. There was no audit mechanism. No one knew who is doing what. For example, one tester could just download the database, and no one knew this. And half of a lot of corporate servers had updated software. I mean, they didn't allow encryption. Zatko claimed that the server don't allow encryption. And this is something I wouldn't expect from Twitter. I mean, that's a big company. So this is the advice for you. Plan your work. Plan logging, audit mechanism, plan testing environment, use testing environment, and some other things that were published by Zatko. We can read that. Data couldn't be deleted. The Twitter had so much mess in the system that your data won't be deleted even if you ask for this. They have so many servers, they don't know what's on these servers. I mean, and also about the bots, we know that Elon Musk wanted to buy Twitter, but there is something going in the cart right now about this. So Zatko claims that there are bonuses for growth rates. So no one in the company is interested in delete fake accounts and bots. Also about the agents from other countries. There is a high possibility of that in the Twitter there are employed hackers from Indian government and also American government. Looking at the production, they can access probably our data, all of our data, our cookies. Looking at the systems, we don't know what's going on with this Twitter right now. And the last thing is that the Twitter is hiding information. They're hiring audits, but they are also censoring it. And no one in Twitter wants to hear bad news. When there is a report, it had to be censored before they publish to the other departments. Because Twitter is so scared that the reports will go to the public that they're better to censor it than show it to other departments. And these are the main concerns of March. But we don't know what we don't know. The whole report that was published from March is censored because of the papers he signed. It was just looked by the lawyers and censored many times. But also hearing from the court side, we don't know many things about Twitter. Thank you for your attention. Yes. No questions. Okay. Yeah.
Do you use Twitter?
No, I don't have an account. I know that people from my family have an account, and they are using Twitter very much, but I was never that interested to create a, or maybe I did for the university. I did create one fake account just to search for the bots, but didn't post anything. It was just fake email.
Great.
Thank you.
Don't forget to share your screen. Guys, you have some chairs here if you want to be more comfortable. I suppose. There is one comment online for you, Natalia. Nice presentation.
Thank you.
Okay, I hope so. So, I believe from the previous presentation, if you change the name of Twitter to Facebook, LinkedIn, whatever else, it will be the same. Or at least almost the same. And after this presentation, I think that this topic is not really important right now. Right, so let's talk about infrastructure as code a little bit and how to make sure that our infrastructure is secure. Right? I had a lot of discussions with my colleague who is one of the most important people in this company related to security, and he said to me a couple of things, and we had a very interesting discussion. This is my version. Security slow us down. I am DevOps, not a security guy. So I don't like it. No developers. No one likes it. But my colleague said that I hate DevOps because we don't think about security. And you know what? It's right. When we talk about DevOps, when we take everything what Agile gave us, right? What Agile is love, right? The speed, continuous deployments, continuous integration, continuous improvement. Right? Where is in this chain where we can put the old way of doing security? Right? So if we have pen test once per year, because this is expensive, right? It means that the deployment which we do next day, the pen test is obsolete at this moment, right? And what about the companies like AWS where the deployments are going like every 7 seconds? Of course, not for one service, but right? So it's quite impossible to connect these two worlds. It is? No, it's not. So my name is Pawel Piwosz. I am City Foundation Ambassador, DevOps Institute Ambassador, and AWS community builder. So I have a lot of free time in my life, and I work for EPAM Systems for 3.5 years right now as a system engineer. I'm leading DevOps Academy, where I teach people how to become DevOps. Well, the DevOps as I understand DevOps, and I knew it a little bit, so they are with as well. And also I'm part of something that is called NGEX. This is an engineering excellence team. We do assessments of other companies about their engineering. So how good are they? So what is infrastructure as code? Who can tell me? Come on, don't be shy. In general, in high level, what is infrastructure as code? I know you in the last in the last row. Mm-hmm. Mm-hmm. And you are wrong, because infrastructure as code is a fast, dynamic, programmable way to deploy hidden misconfiguration of the infrastructure everywhere. Right? And yeah, that's true. Because, spoiler, when I prepared to this talk, and not only this talk, but this topic, I did a scan of many available Terraforms, CloudFormations, etc., in GitHub. Who can tell me how many of them, what is the percentage where I didn't find anything. 0. Exactly, right? So, well, that's the point. And what we deal with. So we had the example of Twitter, right? So this is, come on, Twitter was enough, right? But in 2020, you probably heard about SolarWinds, right? And then it came again. Right? Everything what is nasty come with pairs. So few companies more, right? So all of them really were hacked, were breached, whatever else, right? News from last month. I will not add yours. This airports, etc., etc. It is quite again, let's say funny, right? But yeah, after Uber was hacked, did you see what happened on LinkedIn? They had like 30 positions open for the security immediately. The whole list. Right? So, well. So let's take a look at some numbers, and this will be maybe boring, but maybe it will give you some impulse in your head. So what is the average cost of the breach in 2021, I think, from the IBM and Ponemon Institute reports? $4 and $35 million. This is average, right? From the things they were able to capture. So generally big companies, enterprises, etc., etc., right? Average time to identify and contain the issue, 277 days. And this break is on purpose, 277 days. And 207 days is to identify, so to realize, oh, we were hacked, and then 70 days to fix it. Okay? Industry with the highest cost, obviously the picture is here, healthcare, 10 millions per breach. What a number, I want this on my account. Average cost per record, which was stolen, right? $164. For your name, for your name, for your name, for your data, credit card, I don't know, insurance number, etc., etc. Right? And now the interesting things, we are going to cloud finally. Percent of the cloud-based breaches in the whole number of breaches in this report. How do you think? 45%. Right? So that is the number which can say us how secure our clouds are. And not the cloud like AWS, I don't know, Oracle Cloud, Alibaba, whatever else, but our infrastructure there and our application in the cloud, right? Percent of breaches caused by cloud misconfigurations. And here we talk about infrastructure basically, right? 15%. So maybe not that big number, but still, if you take 100 companies, it means that 15 of them was already breached because of this. It doesn't mean that they do not have this misconfiguration. But nobody found that probably, or they didn't say that. Right? Because there are two types of companies: those who were hacked and those who knows that were hacked. Right? And average cost caused by cloud misconfigurations, 4 millions. Again, I want this money. What kind of cloud misconfigurations we can identify? The most popular one, or ones? How do you think? Secrets are there, but the most popular are some different ones. So let's take an example. Imperva, 3 years ago, so old times, right? When dinosaurs was on Earth. They lost customer records like API keys, TLS, etc., etc. Right? Why? Because they had wrong configuration of network. They had hard-coded API keys. Who didn't do that? Let's throw the first stone, right? And not encrypted records in database. How long it takes for them? 10 months. Very secure, right? Next one, Capital One, the same year. They lost 100 million records, right? Or they exposed, the 100 million records was exposed, like bank accounts, social numbers, especially in US. This is quite important information, private information, right? Because IAM policies were wrongly configured and they had unencrypted storages, right? So how many of you have encrypted storages in your accounts? Okay, so please remember, I can send this slide to you. So what kind of deployment exposures we have? Oh, sorry. 93% of findings there were misconfigured storage, right? So years ago, AWS by default had S3 storages available publicly. Of course, you had to do something more to really publish it, but that was general rule from AWS. It was publicly available. And believe me, there was like 1,000 crawlers around which went there and looked for this kind of open storages, right? 91% are about misconfigured security groups. Right? Of course, it is not 100% together, but if you have one, probably you have the second as well. 72% it's about hard-coded private keys. And 31% is about unused resources. You can ask what the problem with unused resources, right? It's the same problem like unpatched systems, right? There is something. This is unpatched probably. No one even remember that there is a server which is exposed to the internet with kernel 2 something and thousands of CVs there. And it's like playground for everyone around, right? So those are cloud misconfigurations. But also we have another element which is quite important. It is configuration drift. And here the fun begins. Because when we can catch quite easily the misconfigurations in the initial script, initial approach, it's quite heavy, quite hard to find this in the drift, right? But we will be there. So the fact is that 90% of organization allows you to access production. We can say, okay, what's the problem with that, right? Well, how many of you went to your cloud account and just add something to security group just for 5 minutes, right? And then it was a phone, coffee, whatever, and SSH went open forever, right, to the world. Did it happen? Yes, I did that, right? Another fact, 33% of organization didn't start yet or is in early stage of implementation of security into infrastructure. So now the problem of Twitter becomes a little bit better visible why it happened, right? And this is really unbelievable, right? We talk about DevOps, DevSecOps, security, approaches, etc., etc., and then we are going to the real life and you can forget about this. And now the things will go a little bit more interesting because from the cloud security report done by last year, and they had 300 responders. Like 100 or more of 100 responders suffered a serious breach because of cloud misconfiguration. So the percentage is growing, like we can say from the previous report, right? And almost half of teams had more than 50 misconfiguration per day. Wow. Yeah, that's quite a number, 50 misconfigurations. So like a Swiss cheese is really solid comparing to that, right? And what kind of type of misconfigurations we have? Again, unused security groups, abandoned resources, not enabled logging, yet Twitter is example, right? They do not know what's going on there. There is no encryption at rest. I don't want even to talk about encryption in transit, right? Security groups, IAMs, all kind of misconfiguration you can think of, you can dream of, right? And how they catch issues. And this is crazy in the world of DevOps, right? 33% do manual checks before deployment. So good luck with, for example, CloudFormation with 10,000 lines, right? And 27% catch this after the deployment. And it doesn't mean that this is deployment on test environment. It may be any kind of deployment, right? This is also crazy. How much people need to invest in order to catch issues in cloud configurations, right? So for the best number is on the end. 4% of the teams spend more than 500 hours per week. It means 12 people is involved in that. That's, well, it's 3 times bigger than my team now. Okay. And yeah, that's quite a number, I would say. I'm amazed all the time when I see this slide. So going back to drifts, what are the most popular drifts? Security groups. I told you about example, right? 100% of security of the drifts contains drift related to security group. And the best thing is that many tools we have right now, like for example, CloudFormation itself has this drift detection. It will not catch this. IAM policies. Of course, I will just add this asterisk there just to test something, right? And then I leave it. 82%. Compute resource creation, right? Oh, I will add 1 machine, 2 machine. Well, I will change the size of the machine manually because it's faster than go through the whole DevOps process, right? 48%. Not used and not removed the resources, 23%, right? And finally, CI/CD configurations is 21%. And this is something what DevOps world still doesn't understand, that CI/CD need its own security as well. Right? So is there anything we can do? Of course, everyone loves that. So process first. And I think, yeah. So first of all, we use infrastructure as code. So we have hands here, right? Then we check this. We also harden access for users. So no access to production. How much I don't like it, no access to production, right? There are other ways to do stuff. And no manual integration into infrastructure. Easier said than done, right? And the case what we need to change a little bit in the perception is related to the first slide, right? So we are very quick as DevOps, at least I want to think about this that way. And the security is quite slow, in my opinion, right? I mean, the security in the form of 10, 20 years ago, right? Which is still very popular. This is mine, right? The key thing is that if you find any kind of misconfiguration already deployed, doesn't matter on what environment, it's already too late, right? Like 5 years ago, 6 years ago, maybe a little bit more deeper into dark ages, it was like 30 minutes needed if you deployed Elasticsearch without security, and the time the Elasticsearch was really open, it was less than 30 minutes to be needed to be hacked, right? Checked on real example, right? And we can control our infrastructure before we deploy it, because we have infrastructure as code. We can check it, right? For the application, we have SonarQube, etc., etc., etc. We have tools also for infrastructure as code. So we can use dedicated tools to prevent deployment of this misconfigurations, right? And we can do it into CI/CD. because CI/CD can fail and will not allow you to continue. Right? This is the last resort for us. We can have pre-hooks, we can have pull requests, etc., etc. But this part, CI/CD deployment, is the last moment when we can stop something what is bad. And there is a lot of tools, right? So we have Chekhov, we have Terrascan, we have TFSec, we have CFNNAG, which is only for CloudFormation. We have Snyk, right? They also have tools for it. And today we will compare 3 of those tools. All of them are free. First is Chekhov. It's visible somehow. Second, and Chekhov is offered by Bridgecrew. Then there is Terrascan by Accurix. Right now, it's not Accurix, it's Tenable. And TFSec, which was bought last year, I think, by Aqua, right? And there is one difference between Chekhov and rest of them. Chekhov is written in Python, what means that when you install Chekhov, you install thousands of other things, right? And TFSec and Terrascan is written in Golang. The big benefit of Chekhov is that Chekhov is not only able to scan your Terraform, your CloudFormation, but also everything what is related to Kubernetes. Also GitHub Actions, right? So you can use one tool to scan everything what you have related to, let's say, DevOps tools. Right? All are available as a container, which is quite nice, right? Because you can use them into pipeline, inside the pipeline very easily, right? And Terrascan is interesting because it has API implemented. So you can have this up and running all the time and just send requests to it, right? You don't need to download anything, you don't need to run containers especially for that, etc., etc., etc. And how easy is to implement it? How do you think? In the pipeline. How much work is needed for any of these tools? Yeah, I know you know already. But yes, this is true. This is everything what DevOps need to start using Chekhov to scan its own Terraform template. One line, right? Okay, 2 lines. Pip install Chekhov. Okay. And this is all, really all. And the same will be for Terrascan, and the same will be for TFSec. But there will be 3 lines, because you need to download the executable. Maybe you would like to put it into the proper path, because I am sysadmin from my life, for my whole life, so I need to have this in proper place in my system, and then to execute it, right? That's it. And what you can have after that, this is nice, because this is example from AWS pipeline, from Cloud Build, right? But for other Jenkins, Circle CI, Travis, etc., it will be quite similar, right? We can publish the report, right? And for Chekhov, it will look like this. You will have the full report, what was good, what was bad. You can, of course, fail the pipeline based on this. Why do not use it? How many times in the projects you saw that people are using it? Right, so my another question is a little bit, it doesn't have many sense, because I wanted to ask how many times you see when people are using it, they are suppressing the fail action, right? Because you can do that with all of those tools. You can have this report just to have like a dry run, right? And the pipeline will continue. But this, okay, at least you are aware you have problems, right? That's something. All right, so let's see how it look really in a real example, in real pipeline. Hopefully I will be able to show you this. Where is my, here, all right.
So I have our beautiful console of AWS, and I will go into code pipeline. And I have a pipeline which is failed, and this is the good sign. And in this pipeline, I have all three tools I already mentioned: Chekhov, TFSec, and Terrascan, right? So let me just run this pipeline. So I'm collecting source. I just copied kind of random GitHub repository and do scan on it, right? I don't know, maybe I should send this report to author of this repository, but it's too risky. Right, and now code is collected and my three scanners are up and running, right? So let's take a look on, for example, Chekhov first. So we have the logs. This is still in progress. All right, so we have a log. We can go through this log and see what's happening. In this pipeline, I'm doing this in the most intelligent way. So every single time I download, can I just make it a bigger a little bit? Yes. I download the package and install it, right? So it's not very effective, but well, we all do that, honestly speaking, right? So yeah, the problem with Python is that if I install one thing, I install 1,000 things. Still better than Node.js. When I install one thing, I install 10,000 things, right? So anyway, and right now, as you see, this Chekhov is doing the test, right? And it ended with error, and I cannot find my mouse. All right, it's here. So as you can see, it took some time, but still we found errors. Let me jump into report. We have our report here, and we can see that 87 tests passed and 20 of them failed. And what kind of failures we have? For example, ensure that ALB redirects HTTP request into HTTPS one, right? So kind of basics, I would say. Ensure that load balancer is using TLS 1.2. Okay, right, it will be nice. I would prefer to have at least 1.3, but anyway, still something, right? This may be used as false positive because not all buckets must be replicated, right? Because sometimes the data stored in the bucket is not that important. So this may be treated as a false positive. Keys rotation is not enabled, right? Encryption for S3. Versioning on S3 also can be treated as a false positive, right? What I don't like about Chekhov, that Chekhov is, it's not here, but Chekhov also as a fail will show you that you don't have a description for the rule in the security group. Is this a security risk, really? I'm not so sure. But anyway, so this is Chekhov. Let's see what we have next. We've got TFSec, which failed just now. And similar thing, we have our log. Let's take a look. And the difference here is that what I had to do is to scroll up. Okay, where I am here, right? So I need to collect the executable from GitHub releases. So I'm doing it every single time, very smart. Yes, I am DevOps. Then I install this TFSec executable into USR local bin, just to be a proper sysadmin, to show you that I know my job. and execute the tfsec, right? So every single time, for every single of those three tools, I run this in that way that first I create the report, right, in JUnit format, and also I scan everything what is in directory. So for Chekhov, it will be -d name of the directory. For tfsec, it will be dot, right? And then, of course, it failed here, right? Why it failed? Because we found a few things, hopefully. Yes, we have this report as well. And tfsec shows us only errors, right? And before we had around 20 something, if I remember correctly, let me check. For Chekhov, it was 20. For tfsec, we have 11. So this is the first difference, really important difference between those tools. They are focused on different things. They are showing different errors. I'm sorry, but this is the reality, right? And what we have, again, no versioning on the S3 bucket, no logging on S3 bucket. There is some wildcard in the policies. Very nice finding, right? This is what I said. I will just open everything for everything just for testing, right? On production, etc., etc. So KMS as well, elastic load balancers, etc. Right? Policy is found here for the first time. Chekhov didn't do that, unfortunately. I love Chekhov, but for Terraform itself, I suppose I will use tfsec or Terrascan. Right, so this is a report from tfsec. And what we have next? Our Terrascan failed as well. Let's see, log. The action here is exactly the same like I've done for tfsec. So I need to download the executable, unpack it, and put it into the directory. And then the command is very similar. Terrascan scan, output is in JUnit, and please report, please create report for me. For Terrascan, I don't need to put anything if I want to scan everything what is inside and under my directory, right? And again, it failed. And the report, how many findings it will be? More than tfsec, less than Chekhov, more than Chekhov, less than tfsec? Let's find out. 11 as well. And 19 is okay, right? And now we have also information about valuations, but this time in the report, it's not very informative, right? I mean, definitely less informative than, for example, for Chekhov. Of course, in every single one, we can go and see the solution or the problem. So Chekhov will show you in what kind of file it happened, in what line it happens, what is the solution proposed by Chekhov, right? And let's call it snippet of the code where the problem occurs. The same probably will be for tfsec. Yes. So we see that in main TF, in the between the lines 69 and 77, we have this, and the solution can be found here, right? And of course, we've got something similar for Terrascan, right? Maybe less visually, a little bit worse, but anyway. What is the rule name? What is the severity? In which line, which file? What is the description? And we don't really have the helping hand where to find and how to fix it. This is the difference here. So that is how it looks, right? So as you already saw, it's 3 lines of code maximum. So if your DevOps will say you that, come on, it's too much, right? Just use your leg and send him to the moon, right? Believe me, It's quite powerful tool, and is able to catch things which shouldn't be there, right? Especially if we talk about, well, security is important everywhere, right? But if you talk about healthcare, if you talk about insurance, if you talk about financial institutions, it becomes really, really, really critical, right? Okay, so this was the presentation, and I lost my mouse again. Yeah, I've got it. Right, so let's talk a little bit about drifts. What is the basic problem with drifts? That drifts need to be controlled continuously. Because if I do the drift detection right now, and I do the drift detection next time in a week, I have the whole week to log into my account and do whatever I want, right? And there is always someone who has elevated privileges. I mean it, always. So the problem is that current tools don't cover everything. Right? I gave you the example. CloudFormation drift detection will not catch 100% probable problem with security groups, right? And the point is that we need to be strong enough to say to our managers, no, we can't do this on production directly because this is the security risk, right? Okay, you fired. And this is the problem. This is the really problem. What kind of tools we can use? So for example, yes, this drift detection will work, but not for everything, as I said. We have driftctl. We can use it. This will work also for Kubernetes, if I remember correctly. But kubediff will work for Kubernetes, right? We have really big tools from Bridgecrew, from Tenable right now, not Accurix. So those tools allows you to keep, let's say, the eye on your infrastructure and from one side, and on your repository with the code on the second side, and constantly check for the differences in both sides. And if something will be detected, it can even create a pull request and notify you that some change happened. Do something with that, right? Terraform itself doesn't have this possibility. Yes, we can use verify, maybe not verify, maybe plan, but it's not for this, right? So even for the infrastructure, let's not pretend that we have security, right? Because all misconfigurations will be exposed. It's the matter of time, really. And even in case of simple thing like security, like infrastructure as code, the security is very complex, because fixing of those findings there, there's 20 findings, probably 18 findings will take like 5 minutes of work, but 2 of them maybe will take 2, 3, 4 weeks even, because it's a really big change, right? So don't be frustrated with your infrastructure. Don't waste your time, like 500 hours. Just use scanners for your templates. Questions? Well, you saw that with all stuff which is not really needed, like collecting the package, install it, etc., it took how long? Half a minute maybe. So yes, this is a issue many times, but the question is, let me answer by using the question. How many deployments per day you have? A day, right? So adding even 1 minute to each deployment will take 20 additional minutes, right? is this really that big pain? Having from the second side the potential of having really secure or definitely much more secure infrastructure. Of course, when we blindly look on the execution time of the pipeline, because we love the DevOps measurements like DORA, right? Etc. 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 It will be longer. Yes, I agree. But first of all, we can do some things in parallel. We also can use the scanners in our local environment before we push things into repository even, right? So still, I would prefer to have the scanner inside the pipeline, because I will see clearly what's going on, where I am, where I was, what is the trend, etc. But still, if this is a really big problem, use it locally. Right? Use it in pull request. Without this, you will not go into master. You will be not able to deploy. I hope this answers. Yeah, tfscan, tfsec. Mm-hmm. Mm-hmm. There are tools like the one from Tenable, like the one from Bridgecrew, but they are quite expensive. And this is the issue still. This is quite new on the market. So probably there will be solutions soon, right? What we can do, well, for example, we can use the drift-ctl, and we have like a, I don't know, scheduled Lambda function in AWS and run it constantly, like every single hour, right? And check if things are changing, right? Or even having proper logging, proper audit approach, and do or execute some actions on it. AWS allows us to do it. I'm talking about AWS because I know AWS. But specifically for Terraform to catch it like a quickly, no, there is nothing, right? But it's not only for Terraform, for everything really. Mm-hmm. Mm-hmm. Maybe, yeah. Yeah, the point is, yes, the point here is that we have, like with deployments, right? We have deployment and we have continuous deployment. That's the big difference. Only one word, but big difference, right? Deployment is triggered manually and from time to time, and continuous deployment means that something is looking for changes and deploy these changes when they occur. Mm-hmm. So what is nice about those tools is that you can write your own rule set and plug in, let's say, them to the tool. From my experiments, I would say that 80% of efforts from all of them is related to AWS, right? So talking about clouds like Alibaba, Oracle Cloud, IBM Cloud, etc., they even don't think really seriously about Azure and GCP. So even the big three is not fully covered there. Or probably, you know, people who deploy stuff on Azure or GCP are better engineers than those from AWS, right? Or Azure or GCP is so vulnerable that doesn't matter. But yes, the reality is that most effort is going to AWS for everything, every of those tools, even those which I didn't touch. So they are third party, but still. If there is no more question, I would like to stay in touch if you wish. And yeah, thank you very much.
Guys, thank you for joining. It's all for tonight, unless you have more to talk. Nothing else?
No, it's enough. It's enough. Definitely enough.
Thank you, Natalia, for your presentation. It was really good. Also, Paweł. I would like to add something like sometimes people may think, oh, it's Twitter. Everybody wants to hack these big companies. But as Paweł was showing, believe me, all the companies are targets nowadays. It's about data, not about company itself. So it doesn't matter where you work or how you work, you are a target somehow. And as Paweł was mentioning, for this kind of infrastructure as a code, there is always a breach, always another tool, always something. And as an application security engineer, also advise you put at least one tool, start something, do something, because it's about knowing our problems. And usually companies don't know and they are not aware what's happening, and that's most important. Yeah. So again, thank you for joining. We can have some beers. Of course, you pay. I'm not paying, and I have some time. We can chat and meet each other. Thank you, guys. Thank you, people online as well. I know camera is there.